Greetings. This is a short video to give some additional help with talking about outliers, specifically what type of outliers we're dealing with. So we'll use exercises 7.31 and 7.32 kind of as grist for the mill to help us with the conversation. So in outliers part 1, 7.31, it asks us to identify the outliers in the scatter plot shown below and determine what type of outliers they are. Explain your reasoning. So in A, B, and C, we have an outlier in each one of our scatter plots, and they want to know what type of outlier is present there. So if we take a look at the outlier that we're given here, we take a look at this outlier right there, we see a couple of distinct things about it. First of all, we can see that it is far away from the center of the data. That is, if you look at the rest of the data over here, it is a long ways away from it in a horizontal fashion. So if you think about the horizontal distance away from it, it's quite a bit away from it horizontally. And so whenever that happens, whenever it's horizontal, that means it has a lot of leverage. Small movements in this data point will make a huge difference in what the actual regression line is. And the key thing is that it's very different from the rest of the data from a horizontal standpoint. I mean, hopefully by just looking at this data, you can see that the regression line would have been best given by a line that looks something like that. In other words, we'd put our line through that data. So this data point over here had undue influence on what the actual linear model, regression model that was produced by. So therefore, this particular data point is two things. Obviously, it's an outlier, right? But it's also an outlier that has high leverage. So we'll go high leverage, or high lev for high leverage. And it's also influential. And the reason it's influential is because it has dramatically changed what the regression line model turned out to be. Okay, let's contrast that with part B here when we take a look at this data point. Now that data point again is our outlier, and it is again far away from the rest of our data. If you take a look at this data point and you compare that with this last one, you take a look and you can see that there is a large distance. Put the best color choice here, let's use this. There is a large distance horizontally from the rest of the data. Again, there is a large distance horizontally from the rest of the data. But this time, it's not bucking the trend. And what I mean by that is that it's not changing the shape of the line or the slope of the line. It's is reasonably included in with the rest of our data. So this data point again has high leverage, but we would not consider it influential at this point. It's because it does not change the shape of the line or the slope of the line. Okay. All right, let's take a look at our third outlier that we've got in part C here. So in part C, again, we have a very distinct outlier. And in this outlier, we see that it is in the center of the data. In other words, its horizontal distance away from the rest of the data is not large. It's not disconnected from the rest of the data. It has a large vertical, in this case, a very large vertical difference from the rest of the data. So typically, what that means is that it's not going to have a lot of leverage, and it's not going to have a lot of influence on the data point. So that's just a straight out outlier. So that's just an outlier, and that's it. That's all you are. You're just a strange data point, but you probably are not going to have much huge amount of difference in the line. What it would tend to do is slightly pick the line up this way. In other words, move it up, shift it up from the rest of the data, but the data would all still be stacked around it. Always good to take a look at outliers in your data set and make sure that they were not an input error, or ask the data collection folks if that data really existed. Was it part of the data set? So quick analogy as to why an influential data point has so much control over the shape of the line, and that is because if you think about what we're doing here, is that our linear regression was based on x bar and y bar. Remember that our line always goes through x bar, y bar. It's one of the points on our line. And remember that the mean is sensitive to extreme values. And so just as when we were working with the mean earlier in the semester, our model, our linear model, is going to get yanked around by those extreme values because they're sensitive to those extreme values. All right, let's take a look at 3.2. 7.32 is more of the same, really. It's just more examples to help us kind of get the hang of this. Okay, so if we take a look at 7.32 part A here, what we see is first off that there is a data point that obviously has a large horizontal and vertical difference to it. Okay, and so since it's got both of those, since it's horizontally far away from the center, it's going to be an influential data point. So this has got high leverage and it's influential. So this has got both again. So this has got high leverage and it's influential. And again, we can see what the influence of that data point is upon our regression model, is that we would think our line, a regression line, should look something like that, and instead it's been pulled away because of that data point. Okay, so come back over here in part B and we take a look and we see that we have a data point down here that's again going to have a lot of leverage. And the reason, keep in mind again, what leverage is coming from, as you think about, that's a horizontal distance away from the data set. And see, this has got a very large horizontal distance away from the data set. So this, again, this data point has high leverage, but is it influential or not? So when you're going to decide whether or not it's influential, is to decide whether or not it would have any sort of change in the shape of the line. Now this one is not as dramatic as it was in A from 31, or again A here in 32, but it is having some influence on the line. Take a look at this regression line and see how these are all nicely packed together. You would suspect, as I would suspect at least, that our regression line would look not quite unlike but similar to that. I'm using the line tool so I could do a little better job of showing it to you. Would look like that. Okay, so while it doesn't have an undue amount of influence on our regression line as it did in the previous ones on both part A's, it still is going to have a certain amount of influence here. Okay, so this is high leverage, and let me get the proper tool here. It is again going to be influential. Not near as much as it was in the previous problems in both the part A's, but nonetheless it is. Okay, and then hopefully in part C here you can see the part C's are the same. Again, this one is, since it doesn't have a large horizontal distance away from the rest of the data, it has simply got a large vertical distance away from the data, that it's just an outlier and nothing more. It doesn't have any leverage and it's not going to be that influential on the resulting linear model. Okay, so I'm hoping that that helps you, hoping that that makes you smile when you think about this, in particular with respect to this week's discussion question. And don't be shy if you need more help about asking me questions.